Hey everyone, welcome back to my channel. Today we're diving into something truly exciting in the world of AI, something that could shape the next evolution of intelligent systems. You've probably heard a lot about LLMs like ChatGPT, but there's a new generation of models emerging that may take things a step further. What if AI could go beyond just understanding words and actually grasp ideas the way humans do? That's the promise of LCMs. In this video, I'll break down what LCMs are, how they're different from traditional large language models, and why they might just be the future of artificial intelligence. So stick around, let's get into it. LCM stands for Large Concept Model, and it's a fresh, potentially game-changing approach to AI. Think of it this way: while traditional AI models like ChatGPT process language word by word, LCMs think in bigger chunks. They don't just see words, they grasp concepts. In simple terms, a concept in this context could be a full sentence or an entire idea, not just individual tokens. This means LCMs understand language more like humans, not word by word, but idea by idea. This concept level processing allows LCMs to understand context better, handle much longer inputs, think more like humans by working in a hierarchical structure just like our brains. So instead of just predicting the next word like an LLM would, an LCM can analyze an entire idea and respond with much deeper understanding. So now you might be wondering how exactly are LCMs different from the language models we're already using. Let's break it down. First, core processing unit. Traditional LLMs like GPT process language one word or token at a time. Their job is to predict the next word based on the previous ones. But LCMs operate differently. They don't deal with words directly, instead they work with abstract concepts. Think of each concept as the meaning of an entire sentence or idea. Second, understanding and context. LLMs are great at mimicking patterns in language, but they often lack deep understanding. They might sound smart, but they don't always grasp the full context. LCMs are built for understanding. They analyze the bigger picture, tone, intent, structure, just like a human would when reading a paragraph, not just a line. Third, reasoning and structure. LLMs sometimes learn structure implicitly, but they process in a linear fashion. That means they can miss connections between distant parts of a text. LCMs, on the other hand, use a hierarchical architecture. They reason directly on top of concept embeddings, helping them remember and connect ideas across longer texts more effectively. Fourth, flexibility in output. LLMs typically output words in the same language they were trained on, but since LCMs operate on abstract concepts, their output can be converted to any language or even to completely different formats like audio or images. That's right, they are multimodal by design. Fifth, handling long contexts. LLMs often struggle with very long inputs due to memory and attention bottlenecks. LCMs are optimized for long documents. They can process entire reports or articles end to end without breaking a sweat. This makes them much more scalable, especially for enterprise level applications. Let's now explore how a large concept model actually works step by step using the architecture diagram you see here. We start at the bottom with the input. Step number 1, from words to concepts. The input begins as plain text typically divided into sentences. These sentences are passed through a concept encoder. This encoder is powered by a multilingual embedding model called Sonar. Sonar is capable of handling over 200 languages for text and supports 76 languages in speech, more than double the capacity of most large language models. Each sentence is transformed into an abstract concept, a compressed, meaningful representation, so instead of working word by word, the model now works idea by idea. Step number 2, reasoning in concept space. Now, these concept embeddings move into the core of the system, the large concept model itself shown here in green. This is where the magic happens. The model performs reasoning directly in the concept space, not tied to any specific language or format. And it's built with a hierarchical architecture, meaning it can combine and condense ideas, identifying patterns, and understand the context much more deeply than traditional LLMs. For instance, in a summarization task, it might reduce 5 detailed concepts into 2 concise ones. All of this occurs without needing to look at individual words. Step number 3, from concepts back to language or beyond. Once the reasoning is done, the resulting output concepts are passed through a concept decoder, also powered by Sonar. This decoder translates the abstract ideas back into human language again, in any of over 200 languages. And here's where it gets exciting. The same concepts can be rendered not just in text, but also in other formats like speech or images. So the output can be multilingual, multimodal, and reusable without rerunning the whole model. To sum up, the architecture encodes language into universal concepts, reasons abstractly across long and complex text, and decodes back into any format or language, making LCMs incredibly flexible and powerful, especially for tasks requiring deep understanding and multilingual, multimodal output. As we reach the final part of this journey, let's zoom out and look at what large concept models really mean for the future of artificial intelligence. Traditional large language models have done a great job of generating fluent, context aware responses, but they are still bound by language. They operate word by word, statistically predicting what comes next. LCMs change the game. By working with concepts instead of words, they open the door to true reasoning and not just across languages, but across modalities and domains. We are now talking about AI systems that could plan complex actions, make decisions grounded in deep understanding, and create accurate formats, text, speech, images, even video. Some researchers are already suggesting that LCMs are approaching human level reasoning. Instead of just saying something smart, an LCM can understand why it's smart. That's a profound shift from mimicking intelligence to embodying it. These models aren't just better communicators, they are stepping closer to becoming cognitive agents, systems that can reason, reflect, and adapt in a truly intelligent way. The potential is huge, and we're only just beginning to see what's possible. Let's wrap it up with the key takeaway. LLMs understand words, LCMs understand ideas. That's the shift we're witnessing from language to meaning, from surface level fluency to deep conceptual reasoning. And now, I'd love to hear from you. Do you think LCMs will replace LLMs in the future? Let me know what you think in the comments below. And if you learned something new today, give the video a like and subscribe for more deep dives like this. Thanks for watching. See you in the next one.